Hey guys, welcome to today's lesson. This will be the last lesson probably in the series of quadratic polynomials and parabola. This is on the quadratic identities. Now don't freak out, it's not like the trigonometry identities, certainly not as difficult in my view. It is a little bit weird to start off with, but it certainly gets a lot easier. It probably is freaking you out by looking at this equation that I've written up here, but certainly I'm going to go through it and you'll see that it's not as hard as it seems. I've started just by writing out the ax squared plus bx plus c equals 0, or f of x is equal to this. This is just our quadratic expression, okay? The way that our parabolas or all quadratic equations are set up, or quadratic functions. Underneath, I know it looks weird, okay, and looks difficult, but it's actually not too hard. All I've written here is this formula, okay, is the same formula as here, except I've just put the ones there to show you that this is, I guess, my first equation, where you'll notice that it's pretty much the same as this, but they're all twos. That just shows this is my second equation. This symbol looks like the congruent to symbol, okay? This symbol in this instance is meaning equivalent. So what does this mean? Well, basically it's giving you two different quadratic equations, and I guess it's telling you that they are both equivalent to each other. For example, I could give you a very brush one. You might have something that looks like this. X squared plus 3x plus 4, okay, is equivalent to ax squared plus bx plus c, and asked to find the values of a, b, and c. Well, because we've got this, we know it's equivalent, okay, it's equivalent to, then the 1 is in front of the x squared, so a equals 1. The 3 is in front of the x, so b equals 3. And the 4 is that plus number at the end, so c equals 4. They are not that simple. They certainly aren't that simple, unfortunately, but that's the general idea of it. It's basically telling you if two different equations are equivalent, then the number in front of the x squareds are equal, the number in front of the x's are equal, and then plus numbers at the end are also equal. Okay, so that's the basic gist of what we're looking at. Now let's have a look at a proper example. And as I said, they do get a little bit challenging to start with, but I think once you see a couple of them, they're not too bad. So my first example I'm going to look at is 2x squared minus 3x plus 5. I'm going to ask you to write it in the form of a outside of x minus 1 squared plus b outside of x minus 1 plus c. So as I said, this is going to sound really confusing. You may look going, hey, this isn't that easy. You know, probably don't know where to go, but you're just going through it at the moment, so everything's hard to start off with. So basically, it's telling you that these two things are equivalent. So basically, if I rewrite that again, it's saying that 2x squared minus 3x plus 5 is equivalent to a outside of x minus 1 squared plus b outside of x minus 1 plus c. That's basically what it's saying. In this particular instance, it wants me to rewrite this particular equation so that it looks like this, where a, b, and c would be numbers. So for example, it might be looking like the final answer might be like this: 2 outside of x minus 1 squared plus 3 outside of x minus 1, plus 6. That's how it might look. Obviously, that's not going to be the case because I've just written some numbers out of the top of my head. So how do we start going about this? Well, what I would like to do, I basically want to, let's say, manipulate our second equation to look like the first equation. Okay, well, that's my first equation, that's my second equation. How do we manipulate it? Well, looking at this, I guess the first thing I would look to do would be to expand these brackets here. So if I expand the brackets, well, actually, I'm actually going to expand x minus 1 squared to start off with. So I expand this. Now, I'm going to use the perfect square method, where I'm going to square the first, times the two together, and then double it. Square the last. Expand the next one. So b times x is bx. B times negative 1 is negative b. And then plus c at the end of it. I can obviously then go further and now expand the first one, ax squared, then minus 2ax. I always keep the x's at the end of it, same as the x squareds. And a times 1 is a plus bx minus b plus c. So again, let's reflect about what we're trying to do. We're trying to make this equation here, okay, look like this very first one. Okay, so basically I would like to, and I guess one of the main things you should be doing is look to group the x squareds, the x's, and the numbers, because I want to put it back into this form here. Okay, well, I've got x squared, x, and the number. So how do I do that? Well, I'm going to rewrite this. I'm going to rewrite it as ax squared. There's no other x squareds there. Minus 2ax. Well, I've got a bx here, so plus bx. And then I've got a plus a by itself, a minus b by itself, and a plus c. Now, I know that's not looking too great at the moment, but what I'm going to do, I'm just going to rewrite that again as ax squared. This time, because remember we want to put it in the form of this, so it's a plus. So I'm going to put a plus, and I'm going to put in brackets minus 2a plus b x plus a minus b plus c. Okay, now I know again that has probably looked confusing, and I expect that to happen. I'm just going to move this up to get a bit more room. But again, once you do this quite a few times, it does get easier. Okay, to be honest with you, that's probably the hardest part, to get to this point. Now I've got to there, what I'm going to look at, because it is in the form of x squared, x, and the number, we can see now that my a is in front of the x squared, where the 2 is in front of the x squared there. So straight away I can say that a is equal to 2. I found out one of my letters, so I can basically know that my 2 is going to go there. Okay, my next thing, I've got the minus, I'll put that there, minus 2a plus b is equal to whatever is out front of the x. In this case, it's minus 3. All right, so the problem, I guess, with this one, I need to solve it. Okay, there are two unknowns, but what you have just done, you've just found the value of a. The value of a is 2. So I'm going to put negative 2, I'm going to substitute the 2 into it, and I'm now going to solve to find out what b is going to be. So I've got minus 4 plus b equals minus 3. Add the 4 over, I get b is equal to 1. So I've now got my b value, which is 1. Okay, so that's pretty important. So all I need to do now is to find my last one, which is this plus c. So let's look back at my equation. So I've done the a, I've done the minus 2a plus b. Now I've got this thing here, a minus b plus c. So I've got a minus b plus c. So that is equal to whatever that last term is going to be, 5. Okay, so I'm going to put the 5 there. And now let's solve that one. So again, I've got 3 letters here, but I've already found a, and I've found what b is as well. So let's substitute those into it. 2 minus b, which is 1, plus c equals 5. 2 minus 1 is 1, plus c equals 5. Take the 1 across, we get c equals 4. Okay, that's my last missing one. So now, my very last step is to write my answer. I'm going to write here, again, apologies, I'm running out of space there. I'm going to write out my a, which is 2 outside of x minus 1 all squared, plus the b, which is 1 outside of x minus 1. You don't actually need to have the 1 there. And then plus c, which is 4, which is going to be my equivalent equation to 2x squared minus 3x plus 5. These things are exactly the same thing, but just I've modified it to make it look a little bit different. Okay, look, that's a pretty challenging question, I guess, for the first time. But can I say that there's only going to be 2 real options that they're going to ask you. They're going to ask you to make this look like that. Okay, so manipulate the first one to make it look like the second one, or they might give you different values and ask you to find like what A, B, and C is. For example, we had to find that anyway, A, B, and C. So there are two different types of things they can ask you. Certainly with this stuff, it is challenging to begin with, but as I said, I believe that it gets easier as you move on. Okay, I might throw you another question just so we can see where we're at. So this will be EG2. I'm going to ask you the second one now. So find the value of A, B, and C if x squared minus x is equivalent to A outside of, x, that's an x there, plus 3 all squared, plus bx plus c minus 1. Okay, so this is a solid question they can really ask you. Okay, this time we're needing to find out what A, B, and C are. These values here, A, B, and C, and we're being told that these two particular quadratic functions or expressions are equivalent. So what we need to do is we need to make this again look like that somehow, because then I know numbers in front of the x squared is 1, number in front of the x is going to be -1, and the last number will be 0. So basically your steps don't change. Okay, so I might put this first step there is to expand equation 2. And then 2, if you remember from the last one, group the x squareds, the x and the numbers. And number 3, sub in to find A, B, and C. And I guess if you follow those 3 things, for most of your questions, not all of them, but most of them, okay, you'll be able to answer most of those questions. So let's follow that steps. Now, so expand the brackets. So I'm going to do A outside of, it's a perfect square, so x squared plus 6x plus 9 plus bx, no expanding there, plus c minus 1, no more expanding. But now I need to expand the first bracket, so I've got ax squared plus 6ax plus 9a plus bx plus c minus 1. Okay, so my first one I've fully expanded it, which is great. Now I go to step 2. Group the x squareds, the x's, and the numbers together. Well, my x squareds I'm going to underline in red. My x's I'm going to underline in yellow. Oops, I should just do that part on there. My apologies. And then the other ones left over will be my numbers that I tack on to the end of it, okay, which will be that 9a, that's c minus 1. So let's rewrite that now. So I'm going to have ax squared plus 6ax plus bx plus 9a plus c minus 1. Now, you might want to do that in one hit and sort of, I guess, factorize it and put it back into brackets if you wish. That's up to you. If you get good at that, you can do it, certainly. So I'm going to put that there. Now, remember, we want to put it in the form of plus bx, so I'm going to put plus in brackets 6a plus bx plus 9a plus c minus 1, where you can now clearly see that the a is in front of the x squared, the 6a plus b is in front of the x, and that's my number tacked on the end of it. All right, so look, to be honest, you're kind of nearly there. Okay, you're kind of nearly there. So what I'm going to do now is that last step. Okay, so I'm just trying to move this screen up, and it's not working too well. No, it hasn't worked well at all. Okay, sorry about that. Okay, so my last thing here is sub into find A, B, and C. That means I'm going to look to see my original equivalent equation there. And I'm going to look at what number's in front of the x squared, what number's in front of the x, and what number's in front of that plus number at the end of it. So if I look at that, the number in front of the x squared is 1. So my A is equal to 1. Okay, nice one. It's always very helpful if you are given that one by itself to start with. The next one I know, that 6a plus b is equal to, now look in front of the x, because remember that's in front of the x there. So in front of the x is a minus 1. So equals negative 1. So let's substitute the a into it. So we get 6 times 1 is 6 plus b equals negative 1. Take the 6 across. I get b is equal to negative 8. All right. So hold on. Sorry, negative 6. What am I doing? My apologies. I'm not sure what's going on there. My brain had a bit of an explosion there. My apologies. Lucky I figured that one out though. So before that was plus 6. Opposite of plus 6 is the minus 6. Minus 1 minus 6 is minus 7. Okay, it looked like an idiot then. And then the last one is our 9a plus c minus 1, which is equal to, now, a lot of people freak out because there's no number there. So that means that the actual number is plus 0. So that's going to equal to 0. Now, just be careful. One of the things I see when people rush this, they love to put the a in, so which is great. 9 times 1 is 9. But then they tend to put the next number in because that comes next. But notice that that's not b. That's c. Okay, that's the number letter you're looking to find. Minus 1 equals 0. Well, 9 take away 1 is 8 plus c equals 0. Take the 8 across. I'm left with c equals negative 8. So what I've now got, and I might write it up the top there in red so you can see it, I found that a is equal to 1. I found that b is equal to negative 7. And I found that c is equal to negative 8. Alrighty. Look, guys, this has taken a fair while just to do those two questions, go through it. And like I said, look, it is challenging, the idea behind it to start with. However, let me tell you, once you do quite a few of these, even 4 or 5 of them, the actual questions don't really vary too much. If you follow that little rule I've got there of expanding the second equation, group the x squares, x and numbers together and factorize it, then sub-interfine a, b and c, look, you'll be able to probably answer 95% of the questions that they throw at you. All right. So go back to your textbook, do 1,000 examples, check your answers. Any problems, let me know, and I'll go through some more questions for you. Have a great day.